Hello and welcome to the AI Affairs podcast.
We're diving deep today into, I think, one of the most critical questions in tech right now.
It really is. How do we actually measure progress toward true artificial general intelligence? I mean, you hear these buzzwords all the time, right? AGI, superintelligence.
They sound like pure science fiction.
Exactly. But what's the actual, the measurable gap between something like your phone assistant or the big language models we use and a system that could genuinely master any intellectual task a human can?
And that gap is precisely why this new framework has emerged. Leading researchers basically realized that the old definitions, this binary choice of AGI or not AGI, it just wasn't working anymore.
It was too simplistic.
Completely. If you think about AI progress like climbing a mountain, we need markers along the way. We can't just focus on the summit.
So our mission today is to really unpack this new framework for defining what they call AGI stages. This gives us a kind of compass for navigating development, for assessing risks, and for understanding where systems like ChatGPT and Claude, where they actually are right now.
And that's a crucial distinction for everyone, whether you're, building these systems or just trying to regulate them.
Okay, so let's set the groundwork here. For the longest time, the whole discussion around AI was really split into two big camps. On one side, you had what we called narrow AI, systems that were fantastic at one specific job.
Like a self-driving car or a fraud detection engine, task-specific.
And then on the complete other side was the hypothetical goal, AGI, or strong AI, the system that has generalized intelligence that can learn and adapt to basically any intellectual task a human can do.
But the thing that's so fascinating is that the technical engine behind it, all deep neural networks, new learning algorithms, it advanced so quickly that the old binary just kind of broke down.
It's not a switch anymore. It's not off or on.
It's a sliding scale, absolutely. Just saying we're moving towards strong AI became almost meaningless because we started seeing systems that showed glimmers of general capability without being fully general.
And that's what led to this staging framework.
That's it. Defining AGI in stages is crucial for a few reasons. First, it brings clarity. It moves the whole conversation from philosophy to, practical, quantifiable evaluation.
Okay, so it makes it measurable. What else?
Well, second, the risk profile changes dramatically at each level. The dangers of what they call an emerging AGI are completely different from a virtuoso AGI. You need different safety precautions.
That makes sense. And I suppose for the researchers themselves.
Third point, exactly. It directs research. It gives engineers clear, objective targets to aim for. And finally, it creates a transparent basis for communication. So researchers, policymakers, and the public are all basically using the same map.
It's a roadmap instead of just staring at this distant theoretical destination. So let's look at that map. How does this framework actually categorize AI capabilities?
It breaks it down into stages based on two main criteria, performance and generalization.
So how well it does something and how many things it can do well.
Precisely. The whole scale ranges from level 1, which is emerging, all the way up to superhuman, level 5 or higher, which would mean it surpasses human capabilities in, all areas.
And it's not just about the depth of ability, like how well it writes a poem, but also the breadth.
The breadth of application, yeah. How versatile is it across completely different domains? Can it go from physics to poetry to financial modeling seamlessly? That's the real test of generality.
Okay, so here's the question everyone asks, the real-world test. Where do the current state-of-the-art models we're all using, where do they land on this new scale? Are they AGI yet?
According to this framework, they sit firmly in the emerging AGI stage.
Level 1.
Level 1. They show significant promise in a lot of subtasks, and they certainly feel intelligent. But they consistently fall short of level 2, which is defined as competent AGI.
So what's stopping them? What's holding them back from being competent? I mean, they can write essays, summarize documents, even generate code. What are the specific deficiencies?
It really comes down to reliability and consistency across the board. While they're amazing at language tasks, they fall short of level 2 because of unreliable performance in key areas.
Like what?
Specifically, complex multi-step reasoning, mathematical deduction, and probably the biggest one, guaranteed factual accuracy across a truly broad spectrum of topics.
Right. A competent human can be reliably hired for a job.
Exactly. You can trust them. Current LLMs, you can't quite pass that reliability test. They might get 80% of the facts right, but that 20%, that hallucinated information or the inability to solve a slightly new math problem, that means they fail the competent benchmark. They really struggle with things like causal reasoning, which is essential for true intelligence.
This really shows what we have to move beyond just simple tests, like asking them to identify pictures. The source material talks about needing ecologically valid benchmarks.
Yes, tests that actually mirror complex, real-world human tasks.
And that means testing for things like true creativity or complex social competence.
Understanding nuance, irony, intention,
Hmm.
and maybe the hardest one of all, metacognition.
Metacognition.
Yeah.
Thinking about thinking.
Yes. The ability to learn new things efficiently, to understand the limits of your own knowledge, and to adapt your learning strategy on the fly.
Mm.
We have to measure the abilities humans genuinely rely on in unpredictable situations.
If an AI doesn't know what it doesn't know, it just can't be considered truly competent or reliable.
Exactly.
So this is where it gets really interesting, because the AGI stage describes what the system can do, but there's a whole other layer that determines how it interacts with us. Autonomy.
That is such a critical point. You could have a level 5 superhuman AI that operates as a level 1 tool.
AGI level is about capability, but the autonomy level defines its independence in the real world. A higher AGI level just enables a higher autonomy level. It doesn't. It doesn't force it.
And that decision is always context-dependent and ethical.
Okay, let's walk through these levels with examples, because I think this is going to change how you and I interact with these systems very soon. There are 5 levels, right?
5 effective levels, starting at the bottom. Level 1 is AI as a tool. This is just passive assistance. Think of a simple spell checker.
The human is in complete control. The AI suggests, but it never acts on its own.
Right. Then you move to level 2, AI as an advisor. This is where most current LLMs are today. The AI takes on a big role, summarizing a legal document, analyzing market data. But the human has to consciously activate it, weigh the advice, and make the final call. It informs, it doesn't decide.
So when does the AI start to, share the steering wheel?
That would be level 3, AI as a collaborator.
Yeah.
This is a true interactive partnership. Imagine an AI in a financial trading scenario, working with a human analyst. The human sets the goal, but the AI is actively managing data streams, suggesting moves, and co-executing parts of the strategy. It's peer-to-peer.
And then even more independence.
Level 4 is AI as an expert. Here, the AI starts to drive the interaction. It anticipates what the human needs. It takes the lead on complex tasks, but the human still provides oversight. A future medical system might not just advise on a diagnosis, but fully manage data, suggest tests, schedule things, and only need a doctor's signature at the end.
And the final hypothetical future, level 5.
Level 5, AI as an agent, fully autonomous. The self-deciding personal assistant that operates on its own. That is still, frankly, future music. It requires very high AGI levels and profound ethical trust.
The key thing here is that we can define capability and autonomy separately. And the goal, as the sources keep saying, has to be human-centered AI.
Even if the machine is brilliant, the interaction models have to support human needs and respect our autonomy.
Which brings up transparency. The higher the AGI level, the more we need explainability, or XAI.
Oh, absolutely. If a level 3 collaborator is making choices that affect our lives, you need to know why. If a neural net is optimizing city traffic and suddenly causes a huge jam somewhere, the operators need to look inside that black box and understand the logic. XAI is the foundation of trust.
This whole framework really clarifies the dual edge of the sword here, the immense opportunity and the risks. Let's talk about the economic upside first. What are the transformative applications that justify all this investment?
The opportunities are mainly coming from just unprecedented efficiency gains. In healthcare, it's enormous. Radiologists are using AI to spot subtle tumors in scans, often with higher accuracy than a human alone.
And personalized medicine.
Yes, by analyzing huge amounts of genetic data and lifestyle factors to create treatment plans that you just couldn't synthesize manually.
And it's not just in high-tech fields, right? It's hitting things like logistics and retail.
Absolutely. A company like the German retail group ODTO is using AI to not just predict demand, but to optimize procurement and manage their warehouses. Yeah. They've actually used it to significantly reduce product returns by getting the right product to the right customer.
The productivity numbers being thrown around they're staggering.
They really are. Some studies are suggesting a 20 to 40% productivity boost in many sectors in just 1 to 2 years. The overall economic impact is forecasted to create up to $16 trillion in new value by 2030.
16 trillion.
The incentive to push toward that competent AGI level is just massive.
Okay, that's the incredible promise. Now for the necessary caution. Pushing to level 2 and beyond presents some immediate and very acute societal challenges. What's the counterbalance to that $16 trillion?
The risks are profound, and they need to be managed at every stage. I think one of the most immediate ones is bias and discrimination. AI systems are basically mirrors. If you train them on flawed, biased data, they reproduce and often amplify those prejudices.
Can you give a concrete example of how that data bias causes real harm?
There was a finding from November 2025 that was really specific. It showed how commercial transcription tools were unfairly judging people with certain regional dialects. The AIs, trained on mostly standard speech, started stereotyping people with these accents as unfriendly or uneducated.
And that could feed right into biased hiring or lending decisions.
Downstream, absolutely. It's a direct result of unrepresentative training data.
That's unacceptable. What about the resource costs? The cost just to run these level 1 emerging AGIs?
The environmental footprint is a crisis that grows exponentially with capability. A single complex ChatGPT request uses an estimated 10 to 20 times more energy than a traditional Google search.
So there's this feedback loop where the business efficiency gains are being offset by these massive power and water costs for the infrastructure.
Precisely. The International Energy Agency estimated global data center electricity use could double by 2026. And it's not just energy, it's water. The source material noted that training GPT-3 alone consumed an estimated 5.4 million liters of fresh water.
Just for cooling the servers.
Mainly for cooling. These drains demand transparency and, frankly, sustainable solutions.
Okay, third big risk. The black box and security issue, especially as we move up the autonomy levels.
The lack of transparency in these neural networks, the black box, it makes reliability checks extremely hard, especially for safety-critical systems like autonomous cars. And we know the risks. Hallucination isn't just a funny quirk when an AI invents facts. It's dangerous.
And then there's data poisoning,
where malicious actors can manipulate the training data to intentionally cause biased outcomes. Without real explainability, these vulnerabilities are just incredibly hard to find and fix.
And finally, the big societal one, the job market shift. Where are we seeing the most acute automation?
It's targeting highly structured, repetitive cognitive tasks. Especially at the entry level. We're seeing huge impacts in legal research, accounting, IT support.
The first rung on the ladder in a lot of white-collar jobs.
Exactly. Yeah. An analysis from August 2025 showed a significant drop in job postings for those kinds of entry-level roles since 2023. These tasks are just being swallowed by AI tools, and that threatens to widen the skill gap and requires, unprecedented investment in retraining and continuous learning.
So to address these huge risks, we need boundaries. What's the global regulatory response been?
The biggest one so far is the EU AI Act, which came out in June 2024. It's the world's first comprehensive regulation of its kind. It uses a risk-based approach defining categories like unacceptable risk, high risk, limited risk, and so on.
And it sets rules based on that risk level.
Right. It mandates strict controls and requires transparency and explainability for any high-risk systems like medical devices. It really sets a global standard for responsible development that mirrors the clarity this AGI staging framework is trying to provide.
That regulatory path seems absolutely key to making sure development aligns with human values.
It is, because without it, the drive for capability will always outpace the drive for safety and equity.
So when we put this all together, what's the ultimate takeaway from analyzing this new AGI framework?
I think the core lesson is that AGI is a continuous path we're already on. It is not some sudden binary event. We are firmly in the emerging AGI phase, and we're grappling with these huge capability advances right alongside immediate, tangible risks, bias, energy use, the job market.
The framework gives us the map, but the path itself requires deliberate, human-centered choices.
It gives us the scale for capability, but the critical challenge is still human. Aligning the machine's goals with our values, and not just letting the tech run ahead unchecked.
That's it. We have to consciously choose the right autonomy level for every situation, not just maxing it out because we can. And we have to measure not just technical performance, but also the ethical and societal alignment of these systems.
The future of AGI really depends less on if the technology advances and much more on how responsibly we use the compass that these new frameworks give us to manage that advancement.
Thank you for listening, and see you next time on IA Affairs.